Hello children, today we are starting next unit of chemistry, that is unit 8, redox reactions. So what are redox reactions, where they are used, any important application of redox reactions? Uh, Whenever matter is transformed one kind into another, it takes place through various types of reactions like substitution, addition, elimination, all these different reactions you must have studied. And one very important type of reaction is also redox reactions. So transformation of one substance into another also takes place through redox reactions. It's not only important from the study point of view of your syllabus. Also, it has wide applications in many industries like metallurgical industries, pharmaceutical industries, agricultural industries, the biological processes taking place in living systems, combustion of fuel, whether it is for commercial purpose or for industrial purpose or for even domestic purpose. In every area, redox reactions, they play a very important role, right? Uh, Similarly, the functioning of batteries, whether it is dry cell or it is secondary cells, different kinds of batteries, their functioning also depends on redox reactions. So in this way, we can conclude that redox reactions, they have wide range of applications. So we should know what is the meaning by a redox reactions. So just take few examples to discuss the definition of redox reactions in different categories. So with the help of these few examples, we will talk about redox reactions, that what is the meaning of redox reaction and how this redox word is defined. Like in first reaction, sulfur is reacting with oxygen giving SO2. So for sulfur, addition of oxygen takes place. That's why this is oxidized. So this is the first way to define oxidation. Means oxidation is addition of oxygen. A very simplest way. Addition of oxygen is termed as oxidation. Just check the second case where H2S is converted into sulfur. Means the change taking place is hydrogen is removed. So this is another way to define oxidation, that removal of hydrogen is also termed as oxidation. So this is next definition. Removal of hydrogen is also termed as oxidation. Just examine next reaction. Magnesium is converted into MgS. Means in this reaction, both oxygen and hydrogen are not present. So children, if oxygen and hydrogen are not there, then how do we define oxidation or reduction? Then at the place of oxygen, we use electronegative element term. And at the place of hydrogen, we will be using electropositive element term. So in this case, magnesium is converted into MgS, means it has taken sulfur, that is electronegative element. So we can say oxidation, this is another way to define oxidation, that addition of electronegative element is also termed as oxidation. Just check the next one. Fe3O4 is converted into Fe, means loss of oxygen. If addition of oxygen is oxidation, then understood loss of oxygen is reduction. So here we can say Fe3O4 is reduced into Fe. This is, I am telling, for iron. For iron, this is a case of reduction. Why reduction? Because loss of oxygen. Loss of oxygen. Addition of oxygen, oxidation. So loss of oxygen is reduction. Check the another case. Sodium is converted into NaCl. So how do we define that sodium is oxidized or reduced? What change is taking place here? In case of sodium, addition of chlorine, and addition of chlorine is electronegative element. That is oxidation. So we can say sodium is oxidized because electronegative element is added into this. So if these are the different ways to define oxidation, in opposite way we can define reduction. Like addition of oxygen, oxidation. So removal of oxygen, reduction. Similarly, removal of hydrogen is oxidation. So for reduction we can say addition of hydrogen. Clear children? If removal of hydrogen is oxidation, so addition of hydrogen is reduction. Opposite of oxidation is reduction. Here we are saying addition of electronegative element is oxidation. So we can say removal of electronegative element is reduction. Or you can say addition of electropositive element is also reduction. Like in last example we can see for sodium, for chlorine, addition of sodium is taking place, and sodium is the example of electropositive element. It means for chlorine this is the case of reduction. Why this is reduction for chlorine? Because addition of electropositive element. So in this way, these are some different ways to define oxidation and reduction. And if we check all these reactions minutely, if one element is oxidized, simultaneously second one is reduced. Like here, this is oxidation for sodium, oxidation for sodium. But for chlorine, this is reduction. Similarly, children, try this for all these examples. One more I can tell you, like for Fe3O4, for iron this is reduction because oxygen is removed, but for aluminium addition of oxygen is taking place, and addition of oxygen is oxidation. So in this way we can see both oxidation and reduction, they takes place simultaneously. That's why these type of reactions are termed as redox reactions. So now we have the definition of redox reactions. Means the reactions where oxidation and reduction takes place simultaneously. So try to find the species which are oxidized as well as reduced in all the examples. One I told you. Second, use this definition and try to identify. Now this is another way to explain redox reactions in terms of transference of electrons. For example, if I take reaction of sodium with oxygen, we will get sodium oxide. Similarly, if I take the reaction of sodium with chlorine, gives sodium chloride. Now if we explain these reactions as reduction or oxidation, on the point of view of classical concepts, we can say sodium is oxidized because oxygen is added into sodium. And we know addition of oxygen is oxidation. Previous concept as we discussed, same oxygen is reduced because oxygen is taking sodium and sodium is the example of electropositive element. So addition of electropositive element or addition of hydrogen is reduction. Already discussed this concept. So for oxygen this is reduction. Same for this case, chlorine is the example of electronegative element. Addition of oxygen or electronegative element. That is oxidation. Chlorine reduction because addition of sodium, that is electropositive element. So addition of electropositive is reduction. So this is the explanation on the basis of classical concept of redox reactions. Now we explain in terms of more advanced concept of redox reactions, that is in terms of transference of electrons. So just start this reaction. If we balance this reaction, 2 sodium, half O2 balanced. Now sodium, it's a two-step reaction. In first step, sodium by losing one electron, loss of electron converted into Na positive. To balance, we multiply this reaction by 2. Now check the second reaction where oxygen by losing electron, by gaining of electron, because the electron released by sodium, they are received by oxygen. Because our ionic compounds, in bonding chapter we discussed formation of ionic compounds. Ionic compounds are formed by loss and gain of electrons, or we can say by transference of electrons. The electropositive element, that is sodium here is electropositive. Electropositive element will lose the electrons, and the electronegative element will receive those electrons. So the electrons which are released by sodium, they are received by oxygen. So oxygen molecule, by receiving these two electrons, half O2, so by receiving these two electrons, converted into oxide ion. Now when we add these two reactions, adding the first and second step, we will get 2 sodium plus half O2 gives Na2O. So here loss of electron is termed as oxidation. Gain of electron is termed as reduction. So oxidation means loss of electrons. Reduction means gain of electrons. This is second way to define oxidation and reduction. Oxidation, loss of electrons. Reduction, gain of electrons. Similarly, we can talk about formation of sodium chloride. Again, sodium, as it is electropositive element, so it will lose the electrons, and by losing electron, sodium is converted into Na positive. Just balance this equation also. Second, chlorine, it is the example of electronegative element. So half Cl2, it will take this electron which is released by sodium. So by taking this electron, it is converted into chloride ion. Now if we add these two reactions, we will get that overall reaction. Sodium plus chlorine gives NaCl, combined together through electrostatic forces of attraction. Again, this is loss of electron, means oxidation. This is gain of electron, means reduction. Similarly, we can define oxidizing agent and reducing agent in terms of transference of electrons. Oxidizing agent and reducing agent. As the term is suggesting, oxidizing agent means the substance which helps other species to oxidize. Which helps other species to oxidize. That is oxidizing agent, and reducing agent which help other substance to reduce. So oxidizing agent means it accepts the electron or it will lose the electron. As we are saying, it is helpful in oxidation, and oxidation means loss of electron. So as it is helping in oxidation, means itself will receive the electrons. So we can say oxidizing agent is the substance which accepts electron. In this way, help others to oxidize. So this is electron acceptor. And so of course this is electron donor. So oxidation means loss of electron, but oxidizing agent means the one which accepts the electron. Reduction means gain of electron, but reducing agent is the one which loses the electrons. So we can say the oxidizing and reducing agents, they are just opposite to that of oxidation and reduction. Another topic is redox reactions as competitive electron transfer reactions. To discuss the meaning of competitive electron transfer reactions, just take a very simple example. Take a beaker, and in this beaker we take copper nitrate solution, aqueous solution of copper nitrate. And to this aqueous solution of copper nitrate, we place a zinc rod, right? A zinc rod is placed. The solution is blue due to the presence of cupric ions. Children, cupric ions, they impart blue color to the solution. Remember this concept. And leave this setup for some time. Roughly after 1 hour, you will see that the intensity of blue color will start decreasing slowly. When you continuously keep on observing this setup, you will find that the intensity of blue color will start decreasing. And slowly the blue color, finally what happens? Disappears. Finally, you will find blue color will disappear. And one more change you will observe at final stage, that blue color will disappear. And second change that you will observe is this, that on zinc rod you will find the coating of reddish brown metal. Clear? Reddish brown colored coating you will observe on zinc rod. Now, why these changes are taking place? Reason for these changes. You must have done this experiment in 10th standard also. So what happens here? Zinc rod, as zinc is more reactive than copper, so it will loses the electron. So by loss of electrons, zinc gets ionized and converted into zinc ions. So if one metal is losing the electrons, definitely someone should be there who is receiving these electrons. So these electrons which are released by zinc rod, they are received by copper ions present in the solution. So the second change taking place here is the copper ions, by receiving these electrons, they are converted into solid copper. So now I think we can easily tell why the intensity of blue color decreases by the passing of time, because we know the cause of blue color is presence of copper ions into solution. These cupric ions, they are responsible for the blue color of solution. So when these cupric ions are getting consumed by receiving these electrons, the intensity of blue color starts decreasing. Right? Second change, what is the cause of this appearance of reddish brown coating on zinc rod? Because the copper ions, after receiving electrons, they are converted into solid copper, and that copper metal, we know it is of reddish brown colored metal. So this copper metal starts depositing on zinc rod. That's why this reddish color coating appears on zinc rod. So now overall this reaction, is it a redox reaction or not? Just apply the concept of loss and gain of electrons here. Loss of electron is oxidation. So here zinc is getting oxidized, and gain of electron is reduction. So copper is reduced and overall this reaction is termed as a redox reaction where both oxidation and reduction taking place simultaneously. So this is the meaning by competitive electron transference reactions, that here zinc will lose the electrons and copper will gain the electron because it has more tendency to receive the electrons in presence of zinc as compared to lose the electrons. So of course the forward reaction is fast, not the backward. But if we repeat the same experiment but changing these components, like in next experiment, if I take copper rod here, what change I'm introducing now? Here I am taking a copper rod and dip this copper rod into silver nitrate solution, aqueous solution of silver nitrate, and again leave the apparatus for some time. Now what will you observe? Opposite to this, here the intensity of blue color will decrease and ultimately it disappears. But here you will find that blue color starts appearing. Initially the solution was colorless. Slowly you will find here blue color will start appearing. Reason, in this case, as copper rod is dipped into silver nitrate solution. So copper will lose the electron in presence of silver ions. Here silver ions are present in solution. So in presence of silver ions, copper will lose the electrons, and by losing electron, it is converted into cupric ions. And as we discussed, these cupric ions, they are responsible for the blue color of solution. That's why these cupric ions, they impart blue color to the solution. And the electrons released by cupric ions, they are received by silver ions. And silver ions, by receiving electron, converted into metallic silver, balanced by multiplying with 2. So now this is a case of oxidation and this is a case of reduction. Oxidation, reduction. Overall, it's a redox reaction. Write the redox reaction. Copper, silver ions, 2 moles of silver ions gives you cupric ions and metallic silver. Similarly here also, by adding these two reactions, we may write the overall redox reaction. Here, we can write the overall redox reaction, that is zinc plus copper ions gives you copper plus zinc ions. Clear, children? So now if we compare these two reactions, we can easily conclude that in presence of zinc, copper is reduced. But in presence of silver, copper is oxidized. So on the basis of this, we can easily tell about the tendency to lose the electrons if we compare these three metals only. That zinc is most reactive metal. It will lose electrons most easily among these three metals. I am comparing these three only here because we have taken this example. So the zinc is most reactive among these three metals, and then the second is copper because copper can reduce electrons in presence of silver. So this is, next is copper and next is silver. So this is the meaning by competitive electron transference in case of metals. So, and this series where we arrange the metals in a specific order in which they lose the electrons is termed as activity series or electrochemical series. So this series is termed as, what do we call this series? Activity series, or we may call it electrochemical series. Electrochemical series. where metals are arranged in a specific order in which they lose electrons, and this activity series or competitive electron transference among metals is very helpful to construct galvanic cell. Very helpful to construct what? Galvanic cell. Galvanic cell. Galvanic cell are the cells which converts chemical energy to electrical energy. In detail, we will talk about galvanic cell in class 12th. But what are galvanic cells? Which converts chemical energy into electrical energy.